In 2006, the world got angry at a committee. The International Astronomical Union voted to strip Pluto of its planetary status. After 76 years as the ninth planet, it was reclassified, demoted. The word Plutoed entered the dictionary, meaning to devalue or demote something. Children wrote letters of protest. State legislatures passed resolutions defending Pluto. A California Assembly resolution called the IAU decision a scientific heresy. The public had an opinion, and the public was furious. But here is the thing. Almost everything the public believed about Pluto at that moment was wrong. Not slightly wrong. Fundamentally, completely wrong. And when New Horizons arrived at Pluto on July 14, 2015, after a 9-year journey covering 5 billion kilometers, the world found out just how wrong it had been. This is not the story of Pluto being demoted. This is the story of what Pluto actually is. And it is stranger and more extraordinary than anything anyone imagined before we got close enough to see it. Let us start with the most basic misconception, the one almost everyone carries. Pluto is small, cold, dead, and boring. Wrong. On every count. Pluto is small, yes, smaller than Earth's moon. But small does not mean simple. When New Horizons transmitted its first close-up images back to Earth, the reaction among planetary scientists was not confirmation of what they expected. It was shock. Pluto's surface was not the dead, cratered, featureless rock everyone had assumed. It was alive with geology, mountains made of water ice rising 3 kilometers above the plains, comparable in height to the Rockies, glaciers of nitrogen ice flowing across the surface in slow, viscous rivers, vast plains so young they have almost no impact craters, indicating geological activity so recent it may still be ongoing. A world that had been assumed to be geologically dead for billions of years was in fact one of the most geologically active surfaces in the outer solar system. And then there was the heart. The most recognizable feature on Pluto's surface is a bright, pale, roughly heart-shaped region called Tombaugh Regio, named after Clyde Tombaugh, who discovered Pluto in 1930. The left lobe of this heart, known as Sputnik Planitia, is a vast basin of nitrogen ice roughly the size of Texas. It is one of the most geologically young surfaces in the solar system. No impact craters, none. Something is constantly resurfacing it. The nitrogen ice circulates in convection cells, rising where it is warmed from below, sinking where it cools, turning over and erasing any crater that forms. Sputnik Planitia is not just a feature, it is an engine, a geological system that has been running continuously for an unknown period of time, driven by internal heat sources that nobody predicted existed. Where is that internal heat coming from? On a world this far from the Sun, receiving less than 1/1000th of the solar energy Earth does, the Sun cannot be powering this activity. The answer is radioactive decay in Pluto's rocky core. The breakdown of uranium and thorium produces heat, slowly, persistently, over billions of years, and that heat, combined with the unusual properties of nitrogen ice, is enough to keep Sputnik Planitia active. But here is what makes this truly significant. Below Sputnik Planitia, below the nitrogen ice, below the water ice that forms Pluto's crust, there may be a liquid water ocean, not might have been, may currently be. The evidence comes from the shape of Sputnik Planitia itself. It is a large impact basin, formed long ago when something hit Pluto with tremendous force. That basin should have disrupted Pluto's gravity field in a specific way, but observations show that Sputnik Planitia has reoriented itself to sit at Pluto's equator, aligned with Charon's direction, suggesting that over time the basin migrated to a position of gravitational equilibrium. For that kind of reorientation to happen, there needs to be a layer of mobile material beneath the crust. The most likely candidate is a subsurface ocean of liquid water, possibly 100 to 180 kilometers thick, kept liquid by the radioactive heat from the core. Pluto, the frozen world at the edge of the solar system, may have a liquid water ocean beneath its surface right now. This changes the question entirely, not just for Pluto, for how we think about where liquid water can exist in the solar system. If Pluto, at 5.5 billion kilometers from the Sun, can maintain a liquid ocean through internal heat alone, then the number of potentially habitable environments in the outer solar system becomes much larger than anyone thought. Now let us talk about the atmosphere, because this is where the misconceptions get even more dramatic. Pluto has an atmosphere. This was known before New Horizons arrived, but the details were not. The atmosphere is primarily nitrogen, with small amounts of methane and carbon monoxide. At Pluto's surface, the atmospheric pressure is about 100,000 times lower than Earth's sea level pressure. Thin, almost non-existent by human standards, and yet it is there, and it has weather. New Horizons detected distinct layers of haze in Pluto's atmosphere, extending up to 200 kilometers above the surface. These haze layers form when ultraviolet radiation from the Sun breaks apart methane molecules, and they recombine into more complex hydrocarbons that form tiny particles. Those particles drift downward, coating the surface in a thin layer of reddish-brown material that gives parts of Pluto its characteristic color. The same chemical process happens on Saturn's moon Titan. On Pluto, it is driven by sunlight so faint that it amounts to little more than a bright star in the sky. There are also winds on Pluto. The nitrogen ice in Sputnik Planitia sublimates during the day, rising as gas, and then condenses and freezes at night in cooler regions. This cycle drives a daily atmospheric circulation, and on the western edge of Sputnik Planitia, New Horizons found dunes, fields of dunes made of methane particles formed by wind, stretching across the surface like features you would find in a desert on Earth. Pluto also has a tail, not a comet tail, but a trail of atmospheric gas escaping from the top of the atmosphere and being swept away by the solar wind. Pluto loses its atmosphere slowly, continuously into space. Over billions of years, this loss is significant. The Pluto of the distant past may have had a much thicker, denser atmosphere than the one we see today. Then there is Charon, Pluto's largest moon. Most people, when they picture a moon, picture our own. Earth's moon is roughly 1/81 of Earth's mass, a satellite that is clearly smaller than its planet. Charon is roughly 1/8 of Pluto's mass. It is so large relative to Pluto that the two objects orbit a point in space that lies outside Pluto's surface. They orbit each other. They are, in a real sense, a binary system, the only binary dwarf planet system known in the solar system. Pluto and Charon are tidally locked to each other, the same face of each always pointing at the other, orbiting in a gravitational embrace that has persisted for billions of years. Charon itself turned out to be full of surprises. New Horizons found a deep canyon system on Charon stretching across its surface, roughly 1,600 kilometers long and up to 9 kilometers deep. It makes the Grand Canyon look trivial. The north pole of Charon is covered in a reddish material. That reddish cap is material that escaped from Pluto's atmosphere. Methane from Pluto drifts to Charon, freezes at the pole during Charon's long winter, and then gets chemically processed by ultraviolet radiation into complex organic compounds called tholins. Pluto is literally painting its moon. And then there are Pluto's 4 smaller moons: Styx, Nix, Kerberos, and Hydra. Before New Horizons arrived, they were points of light. When New Horizons imaged them, they turned out to be tumbling, not rotating slowly and predictably like most moons. Spinning rapidly and chaotically, their rotation axes shifting unpredictably in response to the complex gravitational dance of being in a binary system. Moons that do not know which way is up. Now, the planet question. Was the demotion fair? This is where the science gets genuinely contentious. The IAU definition that removed Pluto's planetary status requires a planet to clear its orbital neighborhood of debris. Pluto, embedded in the Kuiper Belt among thousands of similar objects, has not done this. By that definition, it is not a planet. But the principal investigator of the New Horizons mission, Alan Stern, has argued forcefully that the IAU definition is flawed. He points out that Earth, Mars, Jupiter and Neptune have also not cleared their orbital neighborhoods in the strict sense of the word. There are asteroids in Earth-crossing orbits. There are Trojan asteroids sharing Jupiter's orbit. Under a strict reading of the IAU definition, no planet clears its neighborhood completely. The definition, Stern argues, was written to exclude Pluto and nothing else. The vote was also taken by less than 5% of the IAU's membership, a minority of the organization, making a decision that affected how the entire world thinks about the solar system. Arizona, the state where Pluto was discovered at the Lowell Observatory in 1930, passed a law in April 2024 declaring Pluto the official state planet. The Great Planet Debate, a 2008 conference of planetary scientists at Johns Hopkins, concluded with no consensus. The scientific community is genuinely divided. The public has a strong opinion, and the IAU has not revisited the decision. What New Horizons showed, regardless of what we call Pluto, is that the category we put it in shaped how seriously we studied it. For decades, because it was small and distant and classified as a minor planet, it received relatively little scientific attention. A world with mountains and glaciers and dunes and possibly a subsurface ocean and a binary companion and atmospheric chemistry and 4 tumbling moons was assumed to be too remote and too unimportant to warrant a dedicated mission for most of its known history. New Horizons was proposed for the first time in 1989 and only approved in 2001. It launched in 2006. By the time it arrived, Pluto was no longer considered a planet. The irony is precise. The moment we finally visited Pluto and discovered how extraordinary it actually is, we had already decided it was not important enough to be a planet. Whatever you call it, Pluto is not what anyone thought it was. It is not a dead rock. It is not a simple frozen ball. It is a complex, geologically active world with weather and glaciers and dunes and canyons and a possible ocean and a companion it paints with its own escaping atmosphere. It is the gateway to the Kuiper Belt, a vast region of the outer solar system that we had barely begun to understand when New Horizons passed through it. New Horizons is still out there, still moving. As of 2024, it was more than 60 times further from the Sun than Earth, twice as far as Pluto was when it flew by. It has found evidence of a second Kuiper Belt, extending further than any model predicted, filled with objects we have not yet visited, and whose properties we can barely guess at. The solar system does not end at Pluto. It extends far beyond, into a region we are only beginning to explore. And Pluto, which we thought we understood because we could see it as a dot in a telescope for 76 years, turned out to be something we had never imagined. That is not a lesson about Pluto. That is a lesson about assumptions. If you enjoyed this video, consider subscribing. I will see you in the next one.